This is a DC motor, running at 5 volts. It is a very dumb device, and I want to make it a bit smarter. We can see it's consuming 130 milliamps of current. But if I put a load on it, that current changes. And that is how I'm going to get more information out of this motor. Let's find out how. So I want to measure the current through the motor. In order to do so, I place a resistor between the negative of the motor and the ground. Any current going through the motor then also has to go through the resistor. Because voltage is current times resistance, and that resistor remains constant, more current means more voltage at that point in between. So that is where I will connect my oscilloscope. There is a lot of noise in the signal. In order to get rid of it, I will have the signal charge and discharge a small capacitor through a resistor. While that is keeping the noise busy, I will have the rest of the signal for myself. The wires from the power supply to the motor become inductors, because of their length. This introduces noise, so I place a capacitor close to the motor to compensate for it. Usually I want to do this first, but the effect would be less noticeable then, and I really need to show this to you. The signal can be somewhat cleaner, but not in a stable way. This is still a breadboard circuit, after all. But it is good enough to work with. Now that we have a cleaned up signal, we can see it is not constant. Why is that? Well, the inside of the motor is made out of multiple electromagnets. They are switched on one after the other. They also take some time to power up and down, and the same applies to their current consumption. I want to copy the oscilloscope signal to an Arduino. But before I do that, I must make sure the voltage never goes below ground, or above 5 volts. For that, I will place a 5 volt Zener diode between the probe and ground. That will protect me both ways. I also added the flyback diode over the power supply. Whoops! Should only cover the motor. No, it also covers the shunt resistor. Anyways, the circuit still works. This is the first sketch for the Arduino, just to make sure everything works fine. It takes 100 analog readings, 1 millisecond apart, and then dumps that into the serial plotting tool in the IDE. As you can see, this data looks a lot like that on the oscilloscope did. And if I now try to load the motor, you can also see the upper range of the graph become a higher number, exactly like we need it to be. This second sketch is a little longer, and it can actually do something. After taking the samples, it counts the tops and bottoms in the graph and notices the interval between them. This will produce a speed number that is outputted every half second. It will also keep an eye on the current consumption. If current is more than 150% of its original value, It is probably under heavy load, and it will report stall. That's it for now. Thank you for watching.